Hi, Stephen. Thank you very much for joining me today. You're here to talk about the incredible Porsche 919 Evo. Now, you were the technical project lead on that car. So I wanted to, first of all, hear a little bit more about what that role involved and also what you're up to nowadays.
Hi, Scott. Thank you for having me. Maybe we could take a small step backwards. So during the Porsche 919 LMP1 project, I was the director of track operations. And in that role, or at least the idea for the Evo popped up during every debrief when after each session and each practice and each quali, our engineers were saying, even though the LMP1 project or LMP1 regulations were fantastic, they were efficiency based, they weren't necessarily performance based. And there was this continual noise in the background as what if we could unleash the engine? What if we could do this on the car? Because the rules were, I wouldn't say restricting the engineering on the vehicle, but they were restricting the performance of the vehicle. And so the LMP1 times were great, the regulations were great, but the engineers obviously always want a vehicle performing at its ultimate. And you always had these sort of coffee machine conversations. And when the project sort of came to an end at the end of 2017, and Porsche started working on their F1 aspirations at the time, I made a proposal to Andreas Seidel, who was the team principal of the project, and said, we have the resource, internal resource, they're not being utilized at the moment. What if we actually follow through on that conversation of what could our 919 hybrid Evo be like, or hybrid be like, if we had the opportunity to just, turn up the Evo, the hybrid, the 919 to 11. And that was the start of the conversation. That conversation then progressed to a proposal at board level at Porsche. They gave us a very strict financial, constraints with regards to what we could do. And the timing was also quite short because this was around September of 2017. And our target was to attempt a lap record on the Nordschleife during the course of 2018, so obviously in the summer. So it was a very short development cycle, and for a project which was used to much longer development cycles, normally we took a year to develop a car before we then brought it back to the racetrack. So that was the background of how the project sort of was started. And surprisingly, to this day, I'm still surprised the board were supportive because obviously I'm not sure they even appreciated until after we attempted the record what we were actually trying to do here. But they were very cool about it and very supportive, which was sort of a typical Porsche philosophy with regards to this kind of thing. And and then from that point on, I sort of became the technical director or technical project leader of the project, created the basic concept scope for the vehicle, and then worked with our LMP1 engineering team, primarily most of it, to then upgrade the car accordingly to turn it into the Evo. And I can say that process was probably the most fun I personally have had on a racing project so far, because obviously the regulations are ripped up and thrown out the window. And I think all my colleagues at the time still speak of those days quite fondly, because it was more an exercise in how much or how far we're willing to go and how much risk we're willing to take, rather than let's try and get as close to the regulation as we possibly can to optimize performance. So that was a unique challenge in the world of motorsport, and that was obviously quite refreshing for us all at the time.
That's kind of incredible that first of all Porsche allowed you to do that and were willing to do that. So hats off to whoever made that decision. And it sounds like every engineer's dream, right? To say, take this car and let's see how fast it can go. Could you just reiterate what was the time period between when you started on that project in terms of working on the car to when you did the tour with all the lap records?
Sure. So September 2017 basically was the technical kickoff. So there was a conversation where I presented my conceptual thoughts to, let's say, the project leaders or the technical project leaders from the LMP1 engineering group. And then from that conversation, and then that became a conversation to say what we could, this was the idea, how could we get close to that, and then try to at least understand which ones were the low-hanging fruit, which ones were worth the risk, and which ones we possibly couldn't get done in the time and with the financial constraints we had. The car was, I think, we obviously modified the 919. So the modifications were introduced step by step. So I think if I remember correctly, around end of November, early December, we were starting to test a version of the 919 with Evo parts on it. Those Evo parts were also part of the 2018 919 development. So we did take advantage of the, let's say, forthcoming updates to the vehicle that were due to come in 2018. There was a huge amount of software work that was required. So that was all staged from around, let's call it December 2017. And we were testing in Weissach on the proving grounds up until, I would say, March. And then in April, we went to Spa to do our first proper track test, a 3-day test. And then from Spa, we did a test on the Nordschleife, I believe in June. And then the record attempt was later in June. So that was sort of the timeline. So things were happening in parallel. So all the new developments were being worked on from around September and started being phased into the car and onto the car as they were designed, built, and implemented. But we were obviously trying to test, like for example with the engine, removing the fuel flow restrictions and what have you, and remapping that. We could do that straight away. We implemented things like a 4-way brake-by-wire system, and we had those units already available to us. So it was more about a packaging study, getting on the car and then getting the software to work with that, and then starting with the fancy yaw controller, which was all built into that 4-way brake-by-wire system.
Well, before we get into the details, and I really do want to get into the details of that, but from your perspective, once a project like that is underway, and I suppose this was in your proposal, but where do you begin, right? How do you organize which areas of the cars to work on, to look at? I suppose there were some fairly easy areas where you could gain some time because of the previous ruling that you could just open up quite a lot of performance in the car. But yeah, what did that process look like, where you're just mapping out kind of the priority of the stuff to work on and balancing that, I suppose, with the cost versus the gains that it's gonna get?
That conversation was surprisingly straightforward for a couple of reasons. The most obvious reason, which pretty much drove the rest of the development, was the discussion with BBS and Michelin about creating a new tire. So we could actually have made a new tire in the timeline with Michelin, but we couldn't have wheels made in time for the project because we would have wanted something wider. But sadly, let's say the lead times to create the magnesium billets that would have been required were something like 12 months or 6 months, which would have been basically the end of the project. So we were constrained to the same rims that we had for the 919. And as a result, there was a few options that we could have chosen with Michelin, but we decided to stay with the same tire construction as the LMP1 tire, just to help just make it easier, to be honest. Obviously, if we could have, we would have went to a bigger tire, but that was somehow outside the scope of the timing of the project. And that then created some constraints with regards to what we could do. It meant that we couldn't go wider with the bodywork, for example. So then in terms of things that we wanted to do, it also meant that we didn't have to change suspension geometry. There were some changes for the 18 suspension geometry, but that were implemented to help with steering feel and things like that. But we didn't have to update the suspension for new rims and new tire size. So that simplified the project a little bit. We would have done something along those lines if we could have managed to have made rims in time, at that point in time. And we did investigate what the options were, and there was nothing that was feasible. So then obviously the next thing to do is weight, aero, power. So those were the three things that we looked at. And obviously the front of the car, it looks quite different to the standard 919. So there's a bigger diffuser on the front with a active trailing edge. So there's a DRS system we can get to later. There's no headlights. Again, that's weight saving. I mean, the thing doesn't have to run at night. There was a new floor underbody and a much bigger diffuser. There were side skirts that were implemented. And those side skirts were actually, we can get to that later as well. We were experimenting with a bunch of stuff in Spa, and there was a few, I wouldn't call them amusing at the time, but they're amusing now looking back, stories as a result of trying some rubber skirts and things like that. So, but
I was going to say, amusing for who?
Yeah, it was quite funny because I think Neil was driving and the car's making the weirdest sound possible. He thought we'd broken something. It was just these rubber skirts that were oscillating at a very strange frequency, making the most bizarre noise you'd ever heard. But okay, we also had this rear wing which was overhanging on the rear, which made a huge impact to the obviously downforce and efficiency of the vehicle. It also started with that overhanging rear wing. It links together with the diffuser, and that makes the diffuser work a little better. So the aero performance in the car is huge. It's like a 50% increase. And
yeah, I saw that.
We could have actually... Yeah, sorry. Good.
But so you... the tires and wheels were the same. That's one area, and then
the tire construction was the same. The compound was a very soft, special compound from Michelin, which would be something similar in philosophy to an old F1 quali tire.
Right, like a hill climb compound or something.
Yes, something ultra soft. Yeah. So you couldn't even look at it. It started deflecting. It was that soft.
Just dripping in the sun.
Yes.
But then, of course, so in terms of the tub and the base of the engine, that was all, quote, as standard.
Yeah, and that's a funny point because we could have actually put more downforce on the car, but we were limited a little bit by the tire construction because it was designed for an LMP1 style vehicle. And we're also limited by the tub itself because the car was being designed for a set of regulations in LMP1. And the LMP1 regulations have a performance level like this. The Evo's performance level was somewhere else. And we worked quite rigorously with our structures department, and there was a point where they said we can't have more downforce, so we had to come back with what we had planned to put on the car because of the concern that we would crack the tub in places like Raidillon or Rouge or stuff like that.
So you outperformed the kind of the tub of the car and couldn't go any further safely.
Yeah. So conceptually, when you start thinking about a project like this and you're starting from a known point, you sort of get carried away with the promise and opportunity of what's to come. And then somehow reality sets in that your team's already done a very good job at optimizing what we have. And then at one point in time, if you want to increase the performance by 50%, there's going to be consequences. And so we were very, aware of that and monitoring that as we introduced the extra performance on the vehicle step by step by step.
Sure, that makes a ton of sense. So, just to start to run through kind of each area of the car where you made improvements, I suppose we should probably start off with the powertrain. Okay. What did that look like? What did you change? What was kind of again standard on the car?
I mean, the base components were all standard. But we removed, this is the heart of the inspiration behind the project. We removed all the fuel flow limitations and energy limitations. And on the E-Machine, there was a peak power that you could use in the LMP days. and the machine was rated at a higher power level. So we basically just used it at that higher power level, and we ended up with something close to 1160 horsepower. So we had a car that had close to 900, depending on the configuration. I think in the early days it was closer to 1,000, but obviously from 2014 to 2017, the WEC and the ACO were trying to increase the efficiency of the vehicles with their regulations, and the power subsequently dropped, also because the cars were becoming ridiculously quick at Le Mans.
Yeah.
But that wasn't a concern with this vehicle, so we just basically remapped the engine, removed the fuel flow limitations, and ended up maximizing the E-machine, and we ended up with 1160 PS.
Wow. And is that process, from an engineering perspective, is that not simple, but give the engine more fuel, remap it so it can deal with more fuel, and and then you get almost 1,200 horsepower, or is it a case of lots of trial and error testing? Like, are how long did that part of the development take?
I think that was probably the most straightforward part of the project. There was a discussion at one point to put a bigger turbo on it, because obviously we were hungry for more.
You had more fuel, so why not put more air in?
Exactly. But that would have become complicated, and that would have been a proper engineering exercise. And as a result, a bit like the tires, we tried to keep it simple. And our simulations at the time were suggesting that the performance of the car was already inside the window we were intending. So we didn't have to go and chase those glorious powertrain numbers. But like I said, 1160 PS with a car that weighs less than 150 kilos, that was already quite an impressive set of numbers.
Yeah, I guess who drove it first? Was it Neil or?
I mean, on the proving grounds, it was Timo. And Neil did some testing for us, and obviously the record attempt. I wouldn't call it a record attempt because it wasn't scheduled to be the record at that time. But, it happened to be the record.
Just happened
on Spa. I mean, the original calendar was to go back to Spa in the summer, but let's just say it was. Our testing was too successful, so we didn't have to go back to Spa later in the year.
You didn't need to do it a second time.
Basically. So, but yeah, the powertrain was probably the more of the straightforward modifications, because we didn't really. I mean, there was another element to all of this as well. We didn't really want to introduce too many unknowns in terms of actually executing the car or using the car in a reliable and safe manner. And obviously, doing a lap record on the Nordschleife adds its own sort of unique risks. And so we wanted the vehicle to be as robust as possible in order to achieve that as well. So that did drive some of the decisions that were made behind how we utilize the powertrain.
Sure. I suppose, like, from your perspective, yes, having the ability to open everything up and make the car much quicker, it then brings that extra element of not exactly, never be 100% sure exactly if anything's under too much strain or what might happen to the car. Yeah. So I guess that adds an extra element of extra layer of safety that you need to bed into the entire project.
For sure. And I mean, we all know the Nordschleife, and with this vehicle we were traveling through mud curve at well over 300 kilometers an hour, and so if the engine failed at that point in time, because we were close to full throttle at through parts of that corner, the consequence on the vehicle and obviously the driver would have been quite severe. And I mean, the last thing we wanted to do was hurt anyone with this project.
So you've got more power. Now we need some more grip. Let's start off with the aerodynamics. How did you approach improving the aero on the car, and what did you actually change?
Changes were quite immense. So the front diffuser is all new, and the overhang is much longer. So we picked up a significant amount of downforce. Also, regulation free, we could let's say, being more aggressive with how the surface under the front diffuser looked.
What does the extra overhang actually do? How does that work?
The longer the length of the wing, obviously the more load you can generate. So a longer diffuser is giving you more load. So and the front diffuser is typically an area where you can pick up load very efficiently, so not much drag. So that's always ideal. So, and then obviously you put more load on the front, you need to balance that with the rear. But before we got there, then the entire underfloor is completely new. And the front diffuser is probably twice as high as it was before, if not larger. So the diffuser was quite. I think in one of those videos where we did with Neil and Timo after the record attempt, Neil was pointing it out that it's you couldn't see the diffuser before, and now it's kind of huge kind of deal. So it was a big step. And then the rear wing was visually the biggest difference because it was set further rearwards of the car. I think the car is, what was it? It was something like 0.5 meter longer as a result. And I think that extra length is shared between the front end and obviously the rear. And it's a pretty big piece of kit. It's probably one of the biggest rear wings I've had the fortune to utilize in my career in motorsport.
And so with it being further out the back, is that just so it has a bigger leverage over the rear axle?
No, the idea to have it overhanging the rear was to allow it to interact with the diffuser. So obviously it becomes, it creates a sucking effect, which makes the underbody even more effective.
I guess that was going to lead on to my next question about that then. So if you're so significantly changing the floor of the car, does that, how significantly does that affect what happens at the back of the car and in turn over the top of the car, right? Because you're changing it so much from its original design where I suppose the airflow was working very nicely over the car. Yeah. Now all of a sudden you're changing the floor a lot. Was there some worry or, how much development went into making sure that everything joined up nicely again afterwards?
Yeah, we had, sadly they're not there anymore, but we had a very good aerodynamics team during the LMP1 project. And we did a lot of work in CFD. And we even took the car to the one-to-one wind tunnel in Weissach. So there's some nice photos of that, I think, on the internet somewhere. So all that work was optimized. So every modification we made to the underbody of the car was done in a manner where it fits with the remaining parts of what was the 919.
Brilliant. And so I guess with that rear wing being a bit further out the back, is that in order to energize the air coming out of the diffuser as well to make that even more powerful?
Yes. So that link is very useful, and like we said, it makes the underbody even more efficient.
Very good. So in terms of moving on to active aero, the car had like an active diffuser. Am I right in understanding that?
We had an active rear wing and an active front diffuser. So basically, in F1, you have a DRS system on the rear wing, which moves the aero balance forward, which means that you can only really use it in a straight line. And again, due to the loads that we were generating on the car, when we were testing at places like Spa, we needed to make sure that we could actually run the car in a low downforce mode with balanced front and rear aerodynamics to go through a Rouge and Radion. So we had to have an active front diffuser, which then basically changed the position of the trailing edge of the diffuser to reduce the load on the front diffuser to match the reduction of load on the rear wing.
Right. So did it just flatten off the tail of the diffuser so it didn't produce as much downforce?
Basically, yes. Yeah. So it sort of lowered the trailing edge of the front diffuser. And if you look at some of the videos from Spa, which we didn't produce sadly, but they were produced by one of the spectators on that day, coming out of La Source, the car goes to low drag mode, or the DRS is open front and rear, and it just goes down through through Erosion, up through Radion, and then down Kemmel with the DRS Open, which is amazing. And the thing punched out of that corner like nothing I've ever seen before.
So even with DRS Open front and rear, it was still producing enough downforce to go through Eau Rouge flat out.
Yes,
which is insane.
Yeah.
What about Blanchimont?
Blanchimont, yeah, also DRS
Also,
Open
wow.
and flat out. Yeah. I think Pouan was the biggest question mark for us because we sort of needed to keep the downforce, but we weren't sure exactly what the car and tires were going to do. But in the end, it worked out okay.
I guess another reason for the active aero is to reduce the load when you're going, flat out down the straight, right? Because of the tires. Was that an issue?
Yes, no, exactly. We need to manage the vertical load on the tires because the construction was optimized for a different spec of vehicle, and that was a big topic. And basically, the tire performance, particularly with the new compound that Michelin provided, was outstanding. But we ended up having to run the internal tire pressures so high that the tire performance isolated compared to what we were running in LMP1 was probably less. But because we needed to increase the pressures so we can ensure the basic structural integrity of the tires were maintained. And on the Nordschleifer, we ended up with 3 bar of tire pressure in the tire. So and Michelin were and are a fantastic partner, and they're extremely competent in what they do. And during the course of development, the vertical loads on the tires were probably increasing a little bit because the vehicle efficiency was quite high. And at one point in time, the tire pressures obviously started to raise in order to, like I said, ensure the structural integrity of the construction. And so, like I said, Michelin are a great partner, and we were always quite comfortable with how they went about engineering the tire and helping us engineer the tire for this exercise. And everything they did was spot on. Sadly, when you're running 3 bar of tire pressure on a Nordschleifer, the consequence on performance is also rather significant.
Yeah, of course. No, that makes sense. But you need to make sure that the tire is going to be strong enough, right? That's the first priority.
Exactly.
So was the Evo close to producing the same amount of downforce as the race car, even when it had the drag reduction open?
It was more. It was still more.
It was more.
Yeah.
Wow.
But I think the drag was about the same as the low drag configuration of Le Mans. So it was more downforce than the high downforce configuration of the 919, but the drag was lower than the low drag configuration that we raced at Le Mans.
Okay. That's so there's a lot of performance gain there then in the aero.
The aero was a big step. And I mean, the team that worked on that the whole team did a great job, obviously. But the boys who did the aero work on the car were, they had also some constraints, but they did a great job.
Sure. And so you mentioned skirts earlier on. Can you describe to me kind of why they're important and also what they looked like on this car?
Yeah, skirts are important because you basically enclose the underbody, which sort of gives you a suction effect, which increases the load under the car and the air efficiency again. Excuse me. But sadly, due to the side pod design on this version of the 919, there was an opening between the wheel pod and the side pod, which meant packaging a sliding skirt in the side pods was pretty much impossible. So we had to get creative with what we wanted to do with the skirts. And the skirts in the various configurations we tested were all hanging from the floor. The skirt we ran on the Nordschleifer was like a bent skirt, which was articulating from a top edge under the floor. And it worked well, but it was still a sacrificial bit. It increased the efficiency of the car, but probably not as much as we'd wanted to. We did try, like the old days in F1, a bunch of different materials where we had the skirts bolted to the side of the floor and just dragging along the ground. And we obviously saw huge increases in downforce and performance, but in those instances, you end up having probably 6 contact patches on the ground, not just 4. There was a few episodes on Spa when we were playing around with these different variants, where the things were making the most hideous noises, and Neil Yanni was at one point, the first time he heard it, he thought there was a failure in the car, and sort of obviously with a prototype vehicle like this, he said if there is something weird, you stop, you come in, and we investigate. You don't try and close the lab or do anything strange. And it took us about 20 minutes to figure out what was happening, because obviously the rest of the car was fine. And no one happened to think about looking at the skirts at that point in time, or because they're just like pieces of rubber that look pretty innocent. But obviously, when they're in contact with the ground under extreme load and at high speed, they were acting in a, let's say, nefarious kind of manner. So we ended up finishing the test with in Spa with a couple of those, a variant of those. But we ended up scrapping them once we got to the Nordschleife, just due to some of the issues that they were causing.
Right. When you did run the skirts,
the skirts were run always. It was just we had like a thick rubber skirt in Spa, and then we had like a carbon fiber hinged skirt that we ran on the Nordschleife.
Okay, so you developed it as you went along.
Yep.
Yeah, and I suppose the rubber part, was it just like a solid piece of rubber that came down? Was it movable, or you still couldn't even get that in the pod?
It wasn't solid. It was flexible, but the idea was we were trying to recreate some. Like again, we took a lot of inspiration from the F1 in the 80s, and we spoke to one or two of the legends from those times who had some connections to Porsche, and we were chasing a sort of a brush style solution where you could drag something along the ground, but also create the ceiling that that was desirable. And we came, our materials department at Porsche came up with a bunch of different solutions. We implemented or tested 2 or 3 of them, some better than others, but that flexible rubber solution, even though it probably produced the best aero performance, created a bit of drag in a straight line, obviously. And like I said, I don't want to say, it created some form of weird standing wave in the skirt itself, which was what was generating this high-pitched frequency or noise, which Neil was hearing.
Okay.
But this was, like I said, we were constrained in terms of how we could integrate or package a skirt. So we couldn't have something that was sliding up and down into the side pod, because the side pod didn't extend the length of the wheelbase of the vehicle. And so that was a challenge to try and work around that, for sure.
Sure. Okay. Well, I just love the idea of all of these kind of new parts being developed and going on the car, and I mean, also fair play to the drivers as well, right? Like you say, when you're getting into a prototype car like this, it's a different mentality than a normal race car that you've driven for
absolutely,
half a season already.
Absolutely.
So in terms of aero, was there any other changes that you made to the car?
Nothing significant, because already with the 919, the side mirrors were integrated in the bodywork. So those side mirrors were just removed completely just to save weight, but they were outside the airflow. So not really. I mean, the bodywork had to be modified, obviously. There's a different engine cover, but not from an aerodynamic standpoint, just to integrate with the new bodywork. And then obviously the central beam element of the the swan neck mounting of the rear wing was also, and the rear end itself is an engineering masterpiece because the amount of load that was being, fed into the gearbox housing increased significantly. So the structures department also ended up exceeding expectations by making a solution that actually worked. And that's also... This. Sorry?
Sorry, Stephen. I was going to say, I love this kind of cycle where you give it more power, you give it more grip, and then you need to make it stronger, and then you make it stronger, and then you give it more power and you give it more grip, and it's this continual cycle.
Yeah. So it was you're absolutely right. It was a endless optimization routine, because as soon as you moved something, then you had to re-optimize everything else to match. So, and the reason why we have these huge end plates on the rear wing was also to actually help the rear end, stay together when you mount it on the back of the car and sent it out of the pit lane.
Yeah, I just quickly to stay on the aero for a second. We haven't really spoken too much about the diffuser. Mm-hmm. I presume it was just longer and taller. Was it just a bigger diffuser that you put on the car?
Correct. So a bigger diffuser with better integration, with the interaction with the front diffuser and also the T-tray under the monocoque. So all that was now free. So we just modified it in a manner which just helped to improve airflow under the car.
And then the rear wing, again, was it just a wider chord and a wider wing, or was there anything more detailed?
It's all new. All new. So that whole rear wing element was updated and changed for this purpose.
And in what way was it changed?
It's longer and wider. So with a bigger flap. So, it was just, like the whole car was put on steroids, basically.
You said, just put a bigger wing on it, guys. Come on.
Actually, again, we were going to go bigger, but we ended up having to come back due to some of the structural limitations that that kind of load would put on the vehicle.
You need to have a word with the health and safety department, Stephen. It seems like they're a bit restrictive.
No, the problems were the composite structure. It would have needed a new monocoque or a new gearbox housing or something like that. So.
Sure. Yeah. Integral parts of the car all need then making stronger and heavier and so on. Yeah. Okay, so if we're done with aero, you mentioned one of the kind of big three is weight as well. Yep. And I suppose this was a relatively simple area of development, as in, like, if we don't need it, get rid of it.
Yes, basically, like the headlights. There's headlights are missing. The tail lights, which were regulation, were missing. There's a marshalling system, telemetry and ECU on the car, which was no longer required because the FIA weren't monitoring what we were doing. So all the driver cooling stuff out, everything that was not needed was removed from the car. And I think we saved close to 50 kilos. For sure. The whole weight saving exercise was probably more than the 50 kilos, but we have more bodywork on the car. So everything, the front end's a bit heavier, the rear end's a bit heavier. And then there were some reinforcements that were necessary. So we took a bunch of weight out of the car, but obviously by increasing the performance of the vehicle, there's a bunch of weight that has to come back on the car. So the net gain was around 50 kilos.
Well, so still significant, even though you had to beef up some of the areas of the car.
Sure.
And then moving on to the suspension and geometry, was anything changed there? I suppose that is an area that is probably quite expensive to develop, but did you do anything there?
Most of the updates were related to what we were planning for the 2018 car, which sort of never saw the light of day. So there was a bunch of inboard suspension stuff that was updated for that, and some outboard steering kinematics that were updated for that, that we benefited from on this vehicle. And then the pitch link system, or FREAK, so the interlinked front and rear suspension, was updated. And then we added a few extra tools, like an active on-off switch, so we could enable and disable the interaction between the front and rear axle. which was quite useful. So it allowed us to pick the front up when we wanted to, due to the rear axle load. And if we didn't want to in certain parts of the corners, for example, we could delay that interaction. And that was also an interesting tuning tool. It helped keep the aerobalance and load on the vehicle, even though we had some additional active aerodynamic elements on the car, but just help, keep the load where we wanted it on corner exit, for example. So suspension-wise, that's about it. Obviously, the car.
Hang on, can I just cut in there? You say you say that's about it. Let's just take a step back and try and let me wrap my head around this. So, the 919 already had front to rear interconnected suspension, right?
Yep.
And so that's where the front to rear suspension is connected hydraulically, and then also cross. Rear right to...
in the 919 LMP1 car, it was just the front and rear axle. So not the cross, just the front and rear axle.
Okay, so they're hydraulically connected, which gives you the ability to control the ride heights.
Basically, it's a leveraging effect. So you use the rear load on the rear axle to push up the front load. Just the front ride height on the front axle. So it allows you to close the front ride height window and run the car statically lower and have a smaller ride height window operating ride height window on the racetrack. And for the LMP1 car, this was quite helpful, obviously, because with the sports car, with the front diffuser, the front ride height sensitivity is a huge part of the vehicle performance. With the Evo, obviously with the bigger front diffuser again, it's probably even exaggerated even further. But more importantly for this car, with the amount of downforce we had, without the freak, we probably wouldn't have had enough suspension travel to get the static ride height we needed to cover the full suspension travel. So the freak was partially performance, but also it was necessary to be able to operate with the downforce level we had and suspension travel level.
Yeah. Well, you would have had to run it so stiff on the springs that it would have been difficult to drive in the slower speed corners.
I don't even think that would have worked. But yes, basically, yes.
You'd have to be replacing a new floor every 3 corners.
Yes, exactly.
So with the frick then, so just to again have another go at it, because I just want to make sure that I'm completely clear on it and the audience is completely clear on it.
Yeah.
Were you able to control the front and rear ride heights independently as the car went through a corner?
No, we basically could just turn off this pumping effect or this leverage effect from the rear axle to the front when we wanted to. So normally, as soon as you start accelerating out of the corner, the rear load increases, so you start pumping the front axle up. But there are situations where you don't want that, or you want to delay that effect to later, so to keep the front low on corner exit. And we could actually we could switch off this interconnection and then switch it back on when the pressure was where we needed it to push the front up where we wanted it.
So it's not active, but it's
no, it was not active. It was let's say a solid, or it was an active controller, but it was basically switching the interconnection on and off as we needed.
Yes, so it's still happening from the dynamics of the car. You're not actually able to pump to make the front rise up or drop down, but you're affecting what it's already doing.
We did look at an active suspension for the vehicle, but the actuators would have been rather large, so we avoided adding that level of risk and complication to the car.
I was going to say, it sounds like there'd be a very complex, very, very complex arrangement there.
I think the weight was probably one of the biggest concerns with that topic.
Yeah, is that because of all the, I don't actually know how it would work, but all of the control units and then all of the tubing?
More the size of the actuator and how much load that we'd have to generate in order to do what we wanted to pick up the car and what have you. And with with the freak, we're able to achieve most of that benefit without adding significant weight to the car.
Okay, yeah, so it wasn't really worth the extra complication and all the extra weight.
The risk is the biggest topic, because obviously you take something that's completely unknown to the Nordschleifer, and then I think we would have been there for a couple more years rather than...
Yeah, true. The risk of kind of wasting time or the risk...
No, the risk of it going wrong and something bad happening. So
yeah.
I mean, the Nordschleifer is, again, I don't need to say this, but it's no joke. So, there's a few nice stories from Timo saying that there's parts of with the speed of this car, the track turns into a tunnel in parts of it, just due to the foliage and the barriers to making the track feel like a tunnel. So when you start operating at that speed, for sure if something goes awry or the driver doesn't get the expected feedback, there's no room for error, because the consequences are quite dire.
Yeah, and I think it's a point worth reiterating. Really, is that I think we can get quite complacent with, I don't know, Formula One, for example, on a big open circuit, which we shouldn't do, of course. But it's a very different story when you take an incredibly fast prototype car onto a circuit like the Nurburgring. The risk is dramatically multiplied.
And absolutely. And on the during the record attempt day, at one point in time, we were sort of keen to continue, or at least try one more time, because the lap times were coming down quite significantly. But then after the last attempt, which was the record and quite an impressive number, Timo said, Andreas and I looked at Timo, and Timo said, I'll go again if you want me to, but I think that's enough. It's like, okay, no problem. We're good.
Oh,
Thank
really?
You.
Wow.
Yes.
If a racing driver is saying that, then it's
yeah,
time.
Yeah, exactly. It's like, okay, thank you very much. Let's wrap it up here and celebrate. See you later.
Wow.
Mm-hmm.
Yeah, a project like this, especially from the driving perspective as well, because I can resonate with this. It just makes me feel like Formula One probably, was like 50 years ago, 60 years ago, where you're kind of going a little bit into the unknown, and the drivers are taking genuine risk. So, I would still love to have been part of a project like this, of course, but it really kind of focuses the mind.
For sure. And there's also the reason why Timo was selected for this exercise, because he's a 5-time N24 winner. The track's in his backyard. He grew up on it, so he knows every corner like the back of his hand. So, in terms of risk mitigation from inside the cockpit, he was probably the best man in the world for the job. Yeah,
of course. Brilliant. This is fantastic. I love it. And then, so I suppose finally onto the braking systems and into kind of any software that you developed. Okay. Was there any movement in how you slowed the car down?
Yes. Hydraulics in general were a big topic. So not just the brakes, but there was a whole new power steering system that was developed. And due to packaging constraints, there was a tandem power steering pump that was added, which was probably the most unique solution I've ever come across. But the guys, again, did an outstanding job. And I think there was a period of time during the course of the project where we realized that the steering torque and the steering assistance required was so high that the current system couldn't do it. And there was a period of 4 weeks where I probably gained a few of these white hairs by trying to figure out how we can actually find a solution for this project and also allow the driver to drive the car, without... the steering loads were ridiculously high. Can't remember what the increase was. It was something in the order of 30 or 40% higher. And the steering and hydraulics group did a super job at coming up with this super innovative solution, which not only gave us the power steering assistance that was required, but also did it in a way which reduced the hysteresis in the system. So, it was truly outstanding. We also ended up increasing the hydraulic pressure in the system, which also helped a little bit there. And this is something that we never raced before, so there was some reliability concerns, but the guys handled that perfectly. And then obviously there was the brake-by-wire system, which was already on the car, in the LMP1 car. It was used on the front axle, to help blend between the hydraulic and the hydraulic braking and the regen from the e-motor or the e-machine. So one of the easiest things to do in terms of concept was to take the brake-by-wire system and put one at each corner to allow us to independently modulate the brake torque, which would then allow us to create all sorts of interesting yaw control or performance from independently controlling the brake pressure. So from a hardware perspective, this was relatively straightforward to implement because we had the units developed and we just started grouping them together on the front rear axle. Software was a much bigger challenge, and the brake control, the yaw control. So we had a yaw control on the braking. We also had a yaw controller, or we were having a brake input like an ESP system on a road car during on-throttle moments and what have you. And this also increased the performance envelope of the car quite significantly. And the drivers in the beginning, during the software development phase, the drivers could actually didn't like some of the interactions with how the software was working. But again, a big credit to the people involved. By the time we got to the Nordschleife, Timo said it was seamless. And that was a huge undertaking. And I mean, particularly in the time that we had, which was from September to basically June, to get that sorted and running in a robust manner. I mean, there was a lot of testing in Weissach, but also the guys were outstanding in terms of how they implemented that, not only from a performance point of view, but also in terms of safety and robustness. So the system worked faultlessly.
And I suppose something like the brake control on a circuit like the Nordschleife, where there's lots of bumps, there's lots of camber, which are typically kind of harder for a driver to control organically or naturally. I guess the performance gain there was quite significant.
Sure. Because like you said, there wasn't an ABS system, but there was a slip controller. So as the system detected more slip, we would then reduce the amount of torque at each wheel separately, which helped with the braking stability. And then obviously, depending on what the driver was asking for in terms of yaw, there was also a yaw moment that we could introduce with the brake system to help rotate the car. So
wow. Okay. Sorry.
Yeah.
Just to cut in there, Stephen, so I can just break that down as a driver. So,
okay.
So would the drivers arrive at a corner, get on the brakes, kind of, I suppose, with a bit more pressure than you might do if you didn't have any control system, and the brake control system would identify any slip, so the tyre under rotating individually, and then manage that before
Correct.
they went into the corner?
Correct.
Yeah.
Correct.
Wow. And then as they turned in, would it would allow the car to rotate to a certain degree or point?
Yes. I mean, it would take your request from the driver, which is basically steering input, and then try if there was a understeer moment or something like that was introduced into the vehicle, and this could happen for a variety of reasons. Then obviously, with the independent control of the full brake or the brakes on each wheel, we could manipulate them in order to allow the car to have more or even less yaw moment, depending on if there was, let's say, an oversteer moment detected, or something like that. But a lot of these oversteer moments that you normally have on the braking, as you trail braking to a corner, the braking stability issues normally are a slip control issue, and by adding the slip controller by itself, we mitigated against a lot of this stuff. And it allowed us also to run more open or less locking on the differentials and stuff like this, which was also quite nice because it made the car feel a little bit more, let's say, intuitive to drive from a driver input. perspective.
Oh, really? Oh, that's interesting. Because I was going to say, hats off to the drivers, because when you talk about understeer and oversteer control, as a driver, I feel like, I'd like to be in control of that. Thank you very much. I don't want to have the computer do it before as I'm realizing that it's happening.
But it's not really the computer doing it. It's only we're just reacting to what the driver wants in terms of how much yaw we're giving the vehicle. And there was a feed-forward element to the software which helped. I mean, because obviously any time delay between what the driver asks for and what the vehicle is doing is a problem, because that can actually cause issues where the driver's inputs are now out of phase with what the car's doing.
Yeah.
So there was a feed-forward element which over time we implemented and was tuned with the driver, and there was some controls on the steering which allowed him to turn up or turn down some of these gains to make the car a little bit more intuitive to drive.
So was that adjusting the timing of the actual car adjustments that were being made, or actually the severity of them?
There was a bunch of stuff, but there was an ability to actually increase, let's say, the feed forward effect, depending on what the car was doing to respond to the driver's inputs, basically. Okay.
Fascinating. And then would the car actually turn itself into the corner as well using the braking?
No. Nothing close to that, for sure. So the vehicle was always responding to the driver's inputs. So there was no... I mean, I think there was a little bit of power added to the brakes in terms of what the brakes could do, but that was also tuned to the driver's preference. There was... but everything that was happening in terms of the slip control, in terms of the yaw control, was purely a response to what the driver was asking for. So the car could not drive itself. Nowhere close.
No. I'm not saying drive itself, but I mean, I've been speaking to some of the Formula student engineers, particularly the guys who just did the 0 to 100 kilometre an hour record as well. Anyway, he was talking to me about some of the things where they're getting the cars to turn in on the brakes and then turn themselves on the throttle as well. So I didn't know because you had independent control of each wheel, I thought maybe that would be something that you looked at.
We were trying to help the driver rather than take something away from him.
Yeah. Okay. I like that. And then when they'd get on the throttle and drive the car out of the corner, was there any software control at that point with the power delivery?
Sure. I mean, the car's always had a TC system, so there was an evolution of the traction control system, and there was still some form of ESP on the brakes, but we try to minimize that because obviously if you're grabbing the brakes, you're taking energy away from accelerating the vehicle, and being forward drive. And I think the key with any of these cars is actually to get the car rotated quickly in the corner and, late apex and punch out as soon as you can. And with the stability that was inherently in the vehicle due to the downforce, due to the braking system, and due to the front e-motor regen, as long as we could get Timur to rotate the car as he wanted to, he could be on the throttle, and we pretty much, if there was any systems interaction from that point in time, it was rather limited because the car was basically where it needed to be. I think apart from a few of the corners late in the lap on the Nordschleife, on traction, there was limited systems interaction. And then the reason why it came late was due to the 3-bar pressure and the tires starting to overheat, overwork, and so it became a little greasy towards the end of the time lap on the Nordschleife.
Sure. So did they go out at 3-bar or come back in at 3-bar?
The target was to have them come back at 3-bar, but the cold pressures weren't far because we were using heat tire blankets and what have you.
Sure. So. Yeah, it wasn't a huge difference. Yeah. No. So I guess one final question is, what was the feedback like from the drivers when they first got in there and they experienced the kind of extra power, the extra grip? Everything was just better. It's what they've been asking for the previous seasons, what they've been driving the car. Yeah, well, I guess I was smiling.
Yeah, for sure. I mean, the feedback was all positive. Obviously, as the car evolved and got better, the feedback improved. But I mean, the performance level of the car was always stunning. And I think in Spa, all the drivers got out of the car. I think we had Timo, Neil, and also Andre Lotterer at that test. And they all said it was the first time in years they felt their neck getting sore after only a few laps. So it was something to behold. The drivers were all happy, and they still speak of it fondly. I mean, Timo and I still catch up and talk about some of those memories as well from time to time. But personally, for me, seeing that car punching out of La Source was the highlight, because it was just outstanding how quick that car was in comparison to anything else I've ever seen.
Yeah, I would have loved to have seen that in real life. I bet it was. I would have loved to have driven it as well. But it's just a fantastic project, and I think hopefully it got enough kind of marketing value from it that at some point another big manufacturer, if not Porsche, will do something similar in the future.
Yeah, that'd be super cool.
Brilliant. All right, Stephen, thank you so much for speaking to me. I really loved that conversation. It was really insightful. So thank you very much. And again, I know it was a few years ago now, but congratulations on the project. It's inspirational.
Most appreciated. Thank you, Scott.